On our channel today, we will be introducing you to thermal fluid heaters and their advantages over steam boilers. We'd like to invite you to subscribe to our channel to stay up to date with our content. Our company is privately held. We've been around since 1903. We've shipped over 11,000 units since we started, and new equipment ships from our facility every week. Besides thermal fluid heaters, we manufacture some pretty unique products, such as steam generators, high voltage electrode boilers, resistance boilers, deaerators, and other ancillary boiler room equipment. We are proud to serve our numerous industry, municipal, and institutional customers. Now let's get started with our presentation today. Did you know that thermal fluid heaters are used by all different types of manufacturers and institutions? In fact, Vapor Power has provided thermal fluid heaters to the food and beverage industry, textile industry, personal protective equipment manufacturers such as those that manufacture latex, nitrile, and rubber gloves, ocean-going barges, inland barges, and even cruise ships, to name a few. Before going too much further, let's take a few minutes to explain a little more about what a thermal fluid heater is. Before we do that, let's talk about thermal fluid. What exactly is thermal fluid? Is it similar to the oil in your car? Well, it sort of is similar to that fluid. It is the fluid that is placed inside of the thermal fluid system, just like the oil in your car is the fluid that's placed inside your engine. It is designed to be heated without breaking down for a long period of time, similar to the oil in your car as well. There are three primary fluids. They are petroleum-based, which is mainly mineral oils and others, synthetic aromatic fluids, and then specialty fluids. The most common type would be petroleum-based mineral oils made by companies such as Paratherm, Mobiltherm, or Thermanol. Some fluids can be heated to 600 degrees Fahrenheit or even 650 to 700 degrees Fahrenheit. Most package heaters, though, they run at temperatures less than about 650 degrees Fahrenheit. Here is an image of the heart of the thermal fluid system, the heater itself. Let's dive just a little deeper into what exactly this heater does and what the rest of the component parts are that make up the thermal fluid system. What is the actual heater? The heater is a vessel that provides a heat transfer surface between the thermal fluid and the heat source. Most heaters in service are fired heaters, but there are also electric resistance thermal fluid heaters as well. Thermal fluid heaters are often referred to as hot oil heaters, and the thermal fluid itself is also commonly called hot oil. Thermal fluid heaters operate in a closed loop system just like a hot water heating boiler. Systems can be vapor phase or liquid phase, and that liquid phase is the one that would be a closed loop system. We're going to focus on liquid phase heaters. So let's talk a little bit about their design features. Most thermal fluid heaters would be constructed from pipe or tubing, like you can see on the right-hand side of my screen here, this type of pipe. Right over here, there's a radiant section and a convective section. So this pipe is formed into, whether it's a serpentine coil, a helical coil, a double helical coil, a multi-layer coil, or a combination of those, this pipe is formed into coils primarily. Our particular design uses a helical coil, so a helical coil would just be one set of coils in a layer. And then we have a multi-layered coil as well in our design, which is the convective section, which is made up of a minimum of 7 coils. And then in our larger heaters, 20 million BTUs and above, we do 9 layers of coils in those. And this is a picture of what those multi-layer coils look like. This particular design is such that we are trying to retain the heat inside of the convective section for as long as possible to extract the most heat possible from the heat source and then absorb that into the thermal fluid heating medium. All thermal fluid heaters are going to feature welded connections at the end. So the manifolds would all be welded together so that there are no leaks that would be present. A little bit more about some design features. All of them that are fired are going to have a forced draft burner to burn common fuels such as natural gas, number 2 oil, propane, those sorts of fuels. What else you would have would be a pump set, which you can see here in this picture. These are a pair of pumps down here. There would be an expansion tank on top of this structure. You can see this expansion tank here. These are all integrated to the thermal fluid heater system. The expansion tank itself, that is there to do several different things. It's there to ensure the system is flooded. It's there to absorb the thermal expansion as the oil is heated in the system. It's there to separate undesirable water from the system during the startup and cookout process. And it's also there to serve as a buffer between the thermal oil and the atmosphere. These tanks are constructed to ASME Section 8 code, and the expansion tank can be pressurized with nitrogen or it can be vented to the atmosphere. Our preference is that the tank is slightly pressurized. About 5 pounds of a nitrogen blanket is very acceptable. Certainly don't have to be, but they do need to be pressurized if they are not the low point in the system. A thermal fluid heater is also going to feature a manifold to join the heat transfer coils to a main supply and return line. These manifolds are then going to be connected to the system piping. And one thing to note that we're really not going to go into much here at all, but always follow applicable codes, including local jurisdictional requirements when connecting to a thermal fluid heater or installing thermal fluid system piping. Here's a flow diagram of a typical thermal fluid heater that's connected to a system. You can see that the return oil is going to, after it's been used in the process, is going to return back, having given up its temperature, it's going to flow back in. There's a pump that's going to be forcing that recirculation effect, and then it's going to go back into the coils. It's going to be heated up by the heat transfer source, whether that's natural gas being burned, propane, or oil being burned. And then it's going to, once heated, flow out to the system. Again, this pump circulates everything out to the system. Let's talk about advantages of a thermal fluid system versus a steam system. So the processes that I mentioned before, whether that's textiles, food and beverage, etc., a lot of those can be done with steam systems. Some of those processes cannot be done with a steam system. But let's talk about why a customer would want to choose a thermal fluid system. Some of the reasons would be the system is simpler overall. It requires less overall maintenance as well. To give you some specifics on that, a thermal fluid heater and a connected heat load makes up the hot oil system, whereas with a steam system, you've got a steam boiler. You will need to have a deaerator or a feed tank that's heated. You'll need a surge tank often. Sometimes you'll need a condensate tank that's at the low point of a system that's pumping back to the surge tank and catching the condensate. You will need steam traps, and you'll also need a means of blowing down that system, whether that's a blowdown tank or a blowdown separator. And that'll all need to go to a drain that's commonly used each day during regular surface blowdowns and bottom blowdowns in that system. So as you can imagine here, there's a whole lot more component parts in a steam system versus a thermal fluid system. One huge thing as well is that with a thermal fluid system, you do not have any costly chemicals or even a water treatment system at all for the thermal fluid heater itself. You don't have any of those, whereas a steam system, you definitely need water treatment. So you may need a water softener, you may need a reverse osmosis system or other systems. You'll need a chemical feed tank, etc., with a steam system. So not having to put those chemicals into a thermal fluid system can save significant dollars and significant maintenance costs. Another huge thing, especially for anywhere that's subject to freezing temperatures, thermal fluid heaters can be installed outdoors without any concern for freezing. So the thermal fluid is not going to freeze. when installed outside. So you don't need to do any heat tracing on the thermal fluid heater. These are often installed on ocean-going barges that are operating in the middle of cold ocean climates, and they can't obviously freeze up. In many cases, a dedicated attendant is not required. That can save a lot of valuable resources, whether that be a site is restricted with being able to use labor. They don't have enough people as it is to monitor those steam boiler systems. With a thermal fluid system, often, depending on the jurisdiction, no attendant whatsoever is required. And you also avoid the expense of that attendant. Higher efficiency is also a key here for thermal fluid systems compared to steam systems. You don't have any blowdown losses. You also don't need to preheat any of the feed water going into the system. If it's a steam system, you have to have blowdown. You're going to have losses because you've heated that water, and you're also going to have pegging steam. So you need to heat the feed water tank water, or you need to heat the deaerator, and that's going to be an expense in that steam system to maintain that pegging steam. A huge thing is much higher operating temperatures can be obtained, and I've got a little graphic here to show you on that. So this graphic represents the saturated steam temperature compared to pressure, curved line here that you can see. And then we've also got the red line here, which is the thermal fluid temperature. So thermal fluid does not have to be pressurized, it simply has to be heated. Whereas steam, to get that steam hotter, you have to increase the pressure here along this line. So to get 400 degrees or so, you've got to be in excess of 300 psi to get to that 400 degree temperature. Whereas the thermal fluid heater system, you can be at 400 degrees with essentially zero pressure. Thermal fluid heaters can be installed with many different users, whether that's an unfired steam generator as shown here, which we make for our heaters, or whether that's a tank heating, a reactor. You might have a kettle that needs thermal fluid to heat up a medium inside of it. You also might have rollers. Another huge thing is presses. So if you're in the wood products industry, if you need to make plywood or glue-lam beams or OSB board, those all get pressed together, heat pressed together in a press. And that press is often heated by thermal fluid because you have to have the temperature up into a very high range to be able to get those glues to bond together, number one, and then also to get them compressed together as well. Let's talk a little bit more about applications. So in the food and beverage industry, a lot of frying applications. So if you have poultry that needs to be fried, we have a lot of thermal fluid heaters that are installed along with fryers, industrial fryers. We have some partners in the industrial fryer area that our heaters are coupled with very often. And whether that's a chicken nugget being created or whether that's a chicken patty or other product that needs to be fried, French fries, etc. A lot of frying applications. There's other applications as well on the thermal fluid side, sometimes to make actual plastics and things like that. Thermal fluid heaters are needed to actually make the vessels that hold that fluid. Pharmaceutical industry uses thermal fluid heaters as well, whether that's in lieu of a steam system or in lieu of a hot water boiler system. Petrochemical or pharmaceutical companies can use us for that. Asphalt is a huge market as well. All of the asphalt needs to be heated and then bonded into the aggregate material as well. The tire manufacturing process can use thermal fluid heaters along the value stream. Textiles, we do textile companies, whether that's a laundry or whether that's an actual fabric manufacturer that needs to have a substance made in the manufacture of that fabric. A thermal fluid heater might be used there. And then petrochemical, so there's a lot of different tanks that need to be heated to avoid freezing of the chemicals inside the tank or to produce a reaction inside of that kettle as well. Let's talk a little bit about some just equipment examples so you can get a picture of some of our heaters, what they look like, talk a little bit about some of the installations. So this particular heater here, you can see that the expansion tank is up here, the red primed expansion tank. So this is in our production facility being completed. There's a pump skid here, the piping skid, that's all completed at the factory. There's a access area for where the burner is. The burner will be inside the front of this heater. And this is simply a protective cover as this unit would be installed outdoors. And this customer wanted some protection from the elements for burner tune-ups in the winter months versus the summer months when those tune-ups are necessary. Another image here of a little different angle. You can see these pumps. These particular pumps, obviously quite critical here. These need to handle very high temperatures. They are self-lubricated, which is nice because the thermal fluid is obviously has lubricity to it. And then the rest of the pump skid. When we do a tank that is going to be pressurized, the pressurized tank is typically, again, set to about 5 psi, maybe 10. The safety valve, there would be a safety valve when the tank is pressurized with that. A couple other applications here. This one's got a customer that needed a little bit more efficiency out of their system. So they wanted to get another 3 to 4% efficiency. So they installed a secondary heat exchanger on the unit to get that waste heat that's exhausting out of the heater here and put that back into preheating the system to create a very efficient system. We've also done projects where the expansion tank needs to be very low. That's something that we often do for the barge, ocean-going barges and things where they don't have a lot of height in the room where the heater will be installed. So here's a couple of equipment examples for you. And really that's, with that, thank you for listening. Thank you for tuning into our channel. We look forward to putting out more content for you. If you'd like to get more information about our thermal fluid heaters, please visit us online at www.vaporpower.com, or you can call us at 630-694-5500. You can also go to our vaporpower.com website and find a rep there if you are interested or in need of a thermal fluid heater. Thank you very much and look forward to additional content here on our channel.